Welcome back. In this video, we're going to have a look at how we can apply our index laws to simplify a number of mathematical expressions. Now in example 1 here, we have 5x cubed times 2x squared. The way in which we're going to simplify this is we're going to use the index law around multiplication of factors with common bases. So first things first, we'll deal with these coefficients. So we'll get the 5 and the 2. They can just multiply together. But the x's, that's going to become x, then 3 plus 2, like so. Now the coefficients will simplify down to 10. That's a nice easy one. And then we've got this factor of x with the 3 plus 2. That will simplify to 5. And finally, that will become 10x to the power of 5. So this is a nice simple one to start with because pretty much it relies on all of the algebra laws that we've been doing many times in the past. Okay, example 2 now. We have 30x squared divided by 5x to the 5. So what we've got here are two coefficients, 30 and a 5. And then we've got x squared and an x5. And both of these factors are separated by a quotient. So there's the numerator of 30x squared and the denominator of 5x5. What we'll first do is we'll deal with these coefficients here and we'll break them down into their prime factors and see if there's anything in common. Now 5 is a prime, so I don't have to factorize that. But the 30, that's not a prime, that's a composite number. So to factorize, I ask, can 30 be divided by 2? And the answer is yes, it can. So I'll put a 2 and then I'll divide it. So we get a result of 15. Now 15 is still a composite, so I ask, can 15 be divided by 2? And of course the answer is no. But 15 itself can be divided by 3. So we'll divide it by 3 and that will yield a result of 5. So what we find is that the factors of 30 are 2, 3, and 5. So I'll write that out like so. Alright, now we're ready to really get into the question. We are going to apply a simplification process. So we're going to eliminate the 5's like so. And that will leave us with 2 times 3 times x squared all over x to the 5. And then we can bring the x squared and the x5's together because they're a common base. So we'll get 2 times 3 times x to the 2 take 5. And that will yield a result of 2 and 3 is going to be 6. And then the common base of x is going to be 2 take 5, which will be minus 3. So a little bit of a complicated question here. But by simply following the rules about factorization and the index law around quotients, we're able to get to 6x to the power of minus 3. Okay, example 3 now. We have 2x to the 4 multiplied by x to the 5 all over x to the 2 all raised to the power of 3. So we've got three things going on here. We've got in the numerator, well firstly we've got a quotient, and then in the numerator we've got the multiplication of two terms with, or two factors with common bases, and then we have down in the denominator the brackets raised to a power. So the first thing we're going to deal with is the multiplication of common. So we'll bring that down and we'll go 2, then the common base of x, and it's going to be 4 plus 5, like so. Then down in the denominator we have an x squared inside brackets with the 3 outside. So these sort of questions here, we have to do it as piecework. Alright, so that's simplified out. Our next step is to manage the power on the brackets. So to do this, we use our rule around expanding this sort of expression down here. And what we find is that the exponents of inside and outside the bracket are multiplied together. So that's going to yield a result of, well, upstairs we'll have 2x9. Then downstairs we're going to have x 2 times 3. This will yield a result of x to the 6 downstairs and still 2x 9 upstairs. Now we have to deal with the quotient. To do that, we simply bring the common base upstairs, so it becomes 2x, and then we're going to get 9 take 6. This will simplify down to 2 multiplied by x to the power of 3. So what looked rather complicated here turns out to be rather simple over here. Alright, let's move on to example 4. What we have is a double quotient. So we've got this 1 over, and then underneath that we've got a second quotient. In the numerator it's 27 times x to the 5 times z to the negative 3. Then downstairs it's a square root of x to the 2 minus 15. That's all of that is to the power of 0. So a nice simple one here. What looks complicated is rather trivial. It's just equal to 1. So the point of these questions is, don't overcomplicate it. Just look what you have and then manage it. So there's a 0 outside, so inside becomes 1. Nice and simple. Alright, example 5. Here's where we raise the difficulty bar substantially. So we've got 162 multiplied by x squared, where the x squared is in a bracket raised to the power of minus 3, and the numerator itself is all raised to the power of minus 1. Underneath that in the denominator we have a factor of 12. So what we're going to do is we're going to use a number of index laws to simplify this expression down to the best we can. So the first point of attack is what we'll do is we'll actually factorize the two coefficients here. So the 162 and the factor of 12. Factorizing 162, we're going to get our first factor is 2 because it's an even, and the result will be 81 left over. Factorizing 81, we get 3 and 9, and then finally factors of 9 are 3 and 3. So these are our factors here. Now simplifying this out, we have 2 times 3 times 3 times 3, and of course that can be simplified down to 2 times 3 to the power of 3. Now for 12, we're going to have factors of 12 are 2 and 3, or 2 and 6, and then 2 and 3. So this will be simplified down to 2 times 2 times 3, and we can write that as 2 squared times 3. So moving from our top line downwards, we're going to get 2 to the power of, or 2 times 3 cubed, multiplied by x squared negative 3, all to the negative 1. Then down in the denominator it becomes 2 squared times 3. Alright, next step is we're going to deal with the exponents on the brackets. So dealing with the negative brackets, or the exponents on the brackets, we're going to get the minus 1 is going to come inside, but it goes 2 to the negative 1 times 3 to the 3 times negative 1. And then the x squared is unchanged because it's inside a bracket itself, but the power on that becomes minus 3 times minus 1. And then we don't need these brackets anymore. Then we've got 2 squared times 3 still on the bottom. Now simplifying this out, we'll deal with 2 to the negative 1 times 3 to the negative 3, and then that's multiplied by x squared, and that's raised to the, becomes positive 3 now. Then we've still got 2 squared times 3 downstairs. Now dealing with the second negative, or the second power, second exponent on the bracket, we're going to get 2 to the negative 1, 3 to the minus 3. The 2 and the 3, they come together, and we're going to get x to the 2 times 3. This will yield a result of x to the 6, and downstairs is unchanged. Alright, now is where we need to turn our attention to the numbers we have downstairs and upstairs. So we've got a base of 2 and the bases of 3. So we use our index laws around common bases in our quotient. So we've got a base of 2, which has a minus 1, and a base of 2, which has a 2. Then a base of 3 with a minus 3 exponent, and an implied 1 down here. What we're going to use is our quotient rule. So we're going to go 2 minus 1 minus 2 times 3 minus 3 minus 1, and then the x is going to stay the same. Simplifying this out, we get 2 to the negative 3 multiplied by 3 to the negative 4, and then that will become x to the minus 6. So what we'd have here is the simplified version, or the simplified expression that was derived from this expression up here. So still quite complicated, but a little bit better than what we started with. This is probably one of the harder questions you could potentially be asked. Now, example 6, we have another bamboozling example, which will be a showcase of a number of index laws we use. Now we've got 49 to the power of x plus 2, all divided by 7 to the power of 2x. What we're going to do to enter this question is we're going to simplify the coefficients. So to do that, we're going to use a factor tree. So we'll go 49, and the factors of 49 are 7 and 7. So 7 times 7 is equal to 7 squared. So having said that, we're going to go in implied brackets. We'll go 49 is simplified down to 7 squared. And outside the bracket, it's raised to x plus 2. Downstairs, we still have 7 to the power of 2x. Now, dealing with the exponent on the bracket, we're going to multiply the outside with the inside exponents. So 7 is going to become 2x plus 2, then 7 2x. Simplifying, it will become 7 2x plus 4, then 7 divided by 7 to the power of 2x. Now simplifying this out using our division, we're going to get 7 2x plus 4, then we take the 2x. So that will yield 7 to the power of 4. So these 2x's here and here, they're going to cancel. So we get something that looks rather complicated, actually turns out to be something numerical and quite easy to compute. So examples 1, 2, 3, and 4 are a good showcase of the sort of questions that you'll likely be asked in a test. In example 5 and 6, more so questions that you could be asked to do, but they're definitely on the harder end of the spectrum. If you don't understand 5 and 6, then it's no big drama. The ability to be able to do examples 5 and 6 will come after adequate amounts of practice and perseverance.